My name is Haley Smith, and this presentation is on how physics is used in daily activities. There are many different branches of science that may or may not be used daily, and some are used in almost every aspect of daily activity. Physics is a very broad branch of science that the world is very reliant on, and it is involved in almost every daily activity, and people are probably familiar with some physics principles such as speed, velocity, acceleration, force, etc. And these are used almost every single day, whether people realize it or not. Physics can be as complicated as being used to build an airplane to ensure that it functions properly, or it can be as simple as waking up in the morning and getting out of bed. Almost everything a person does or encounters in a day-to-day life is based upon the use of physics, and without this branch of science, it'd be nearly impossible to understand how many things function in daily activities. The basic role of physics. So, physics is used to define different aspects of the universe, some of which include gravity, energy, velocity, commonly known terms. So, physics also is used to describe how things interact with one another. So for most daily activities, there's usually a why and a how of how it works, and this is where physics becomes important. There are many different laws of physics that explain different principles, and these laws are what are used to help decide or describe how things relate and connect to one another. On to physics in daily life. The use of physics starts at the very beginning of the day when a person wakes up. This is the first task that somebody performs to begin their day. And physics plays a role in not only this, but is consistently used throughout the other activities of the day as well. As mentioned, waking up is the first task of every day. An alarm clock may be used to help somebody wake up on time or to help them maintain a certain routine. And how does this work? And how does it wake this person up? The noise of the alarm clock is what will ultimately wake a person from their sleep. And the physics behind this is simple. Physics is sound. A definition for sound is a disturbance which propagates through an elastic material at a speed which is characteristic of that material. As the sound moves through air, changes between different physical quantities can be measured, and some of which are pressure, velocity, temperature, density, and some more sound-related quantities are frequency, speed, and waves. Physics describes how sound happens, and this can be used to measure different properties of sound. So the noise that the alarm clock gives off is described by the properties and the physics of sound. And sound is something that occurs consistently throughout the day. So another physics principle that occurs consistently through daily activities and plays a big role in performing a lot of them. Motion of daily activities. So continue talking about how physics is involved in waking up. When a person gets out of bed in the morning, after they wake up, motion is already taking place. And energy is the physics principle behind motion and is a major property of physics. There are two commonly known types of energy, potential energy and kinetic energy. Potential energy is the energy that an object has when it is stored and when it is in its resting position. And kinetic energy is the energy that an object has when it is moving. Energy when waking up, just before a person wakes up, they have potential energy, and as soon as they open their eyes, that energy is transferred into kinetic energy. And this kinetic energy is what causes their eyelids to move and to open. And although opening your eyes is just a small task, it still requires kinetic energy to happen, because before they were opened, they were closed, and while they were closed, that was potential energy. And energy is required in every aspect of daily activity, even if it's just stored, like it was when your eyelids are closed, or when it's used in small amounts, like opening eyelids. Potential and kinetic energy physics allow many different properties to be measured through formulas and calculations. The formula for potential energy is PE equals mass times gravity times height, which can be condensed to PE equals weight times height, since mass multiplied by gravity equals weight. And the formula for kinetic energy is KE equals 1/2 of mass times the velocity squared, which uses the values of mass and velocity in that equation. Calculating energy in real life. Both potential and kinetic energy of a person waking up can be calculated. If a person weighs 150 pounds and is 5 feet 9 inches tall, their values can be converted into the proper values for physics equations, newtons and meters. 150 pounds equals a mass of 68.0389 kilograms, and when multiplied by 9.8, which is the acceleration of gravity, their weight in newtons is equal to 667.46. For height, it is known that 12 inches are in a foot, so for a height of 5'9", it would be equal to 12 inches times 5 plus 9 inches, which is a total of 69 inches tall. And then inches can then be calculated to centimeters and then to meters to give the proper quantity for physics. Their height is 1.75 meters. So to solve for potential energy of this person, potential energy equals 69.0389 kilograms times 1.75 meters. Potential energy of this person while they're sleeping is 120.818 joules. Now on to kinetic energy. Kinetic energy is a little more complicated to solve for than potential energy, where potential energy you just needed the mass and the height. On kinetic energy, you have to have the velocity and the mass. So for the example, this person gets up at a velocity of 0.5 meters per second. And so kinetic energy equals 1/2 of the mass times the velocity squared, which is the mass is 68.0389 kilograms and the velocity is 0.5 meters per second. And so for this person, when they get up, they have a kinetic energy of 8.505 joules. However, that is at the 0.5 meters per second velocity. So if the person were to get up faster at a faster velocity, they would have a larger amount of kinetic energy, and if they were to get up at a slower velocity, they would use a smaller amount of kinetic energy. So it is dependent on the velocity of how the magnitude of energy they have. So both kinetic energy and potential energy are constantly used in day-to-day activities. So on to more energy-related activities. Walking is one of them. And walking is an activity of movement that is used throughout the day in order to perform many other tasks. Examples are walking to the kitchen to get a glass of water, walking outside, walking for exercise, and many other things. Again, everything that is moving requires energy, and another property of physics, force, is applied when a person takes a step. So when a person moves their foot to walk forward, their hips rotate back and forth, constantly changing angles with each step. The torque of a pendulum can be used as a parallel to a person walking using some of the different properties of physics. So I have a pendulum picture in the corner in case nobody knows in case you don't know what that is. So walking at a natural pace, taking a step requires energy to create motion. So if you're just walking at a pretty smooth pace, you're not having to put much effort into it, then that's because gravitational force is helping bringing the step foot to the ground naturally. And gravity works constantly to keep that plant leg on the ground and helps to move the step leg to the ground while walking. And walking at a slower or faster pace, however, requires more force to be applied to the ground. And the force created by the muscles must then be more than the force of gravity. And so when walking faster or slower, less torque will be created in the hips if you're walking slower, whereas more torque will be created in the hips when walking faster. And so now onto something that is probably a part of most people's daily routine is using a car. So physics of a car allows a person to travel somewhere much faster than it would take for them to walk that same distance. So cars are complex in which many aspects of physics can go into explaining its properties and functions. For example, some physics properties of a car that a car uses: force, acceleration, velocity, inertia. All of those are involved in driving a vehicle. Physics of a car continued. Just like in a person, kinetic energy is required for movement in an object, just like a car. So kinetic energy is what actually allows that car to start up and what allows it to drive. The equation for kinetic energy again is Ke equals 1/2 the mass times velocity squared. So that can show the relationship between kinetic energy and the velocity at which the car is traveling. So for example, if a person is driving a car at a velocity of 100 meters per second, and then they accelerate that to a velocity that is twice that much, so 200 meters per second, kinetic energy will increase 4 times the amount. And this is because of the velocity squared in the equation. Along with energy, there is multiple forces involved when driving a car, one of which is centrifugal force, and this is applied to the car when it is turning, and this force causes the car to want to move to the outside of the curb. And an explanation for this is that when making a sharp turn, the driver and the passengers are often shifted towards the opposite direction of the turn, and this is a result of that centrifugal force pushing those people in the opposite direction or towards the outside of the curve. Another property involved in driving a car is inertia. And inertia is a force that resists change in velocity and direction. And this is supported by the fact that an object in motion or at rest will remain that way until another force acts upon it. So in a vehicle, inertia is created by driving a certain speed in a certain direction. So an easy way to think of force being applied to stop inertia is just simply force being applied to the brakes in order to stop that inertia of the car, or applied to the gas pedal when wanting to accelerate, which increases the inertia of the car. To change direction of the vehicle or to turn down a different street, force must be applied to interrupt that inertia that was created. This force that is applied is centripetal force. So it's applied to interrupt that inertia, and it causes the tires to change direction and move the body of the vehicle. Inertia is wanting the vehicle to remain on a straight path that it was on at the same speed. So this centripetal force has to be stronger than the centrifugal force created by inertia. In conclusion of this PowerPoint, physics principles are used daily. So whether it be waking up or getting out of bed or driving a car, properties of physics play a heavy role in day-to-day activity. Properties such as energy, motion, velocity, inertia, force, and more all play a role in any activity that a person or object can perform. Understanding physics is important to understand how everything works and how the world works, and the relationships between people, objects, movement, and activities. Physics is the why and how behind performing any daily activities. And reference page.